introductions.
Yes.
Mark Hudson,
Recording in progress.
Cloud outreach.
Gary Ross, Grand Rapids Astronomical Association. Tom Servanair.
Cheryl Kaplan.
Alan Kaplan.
Brian Wazinski.
Maria.
Jerry Voorhees.
Jonathan Kate.
Bob Tremblay.
Theo Barton.
Dave Noble. Sonny Spinos. Mike Johnson. John Berger. John Stiller.
All right. Lewis in the back, yeah. So I do not see Parker and Ruth Humantle. They were kind enough to donate the snacks for tonight. So round of applause for Parker and Ruth.
Parker's not feeling well.
Ah, very sorry to hear that. Would have been okay. Do we have any brand new attendees tonight? Fabulous. Where did y'all find out about us?
Online.
Online?
The person sitting too low.
Oh, brilliant. Okay,
That's very wrong.
that's good.
Space Station 3D.
All right. So,
Just not coming over on Zoom. Oh.
You're not coming over on Zoom.
can the Zoom crew hear me now? Is it, or is it the live streaming thing?
I can hear you
I
fine.
hear you fine.
You can hear me. Okay, great.
Oh, this isn't plugged into the audio. For one thing.
Test, test. Okay, we're gonna keep going for now. Um, so tonight we have a couple new attendees. That's fabulous. You can join or renew your membership via PayPal now. So we've got that present, and new members get a lovely lanyard with a name tag. Officer reports. So big news about the banquet. It's going to be held at Ukrainian Cultural Center per our recent tradition. We have changed up the date. The board decided that having the banquet being a couple of days after the Cranbrook meeting was a little too rushed. So we've moved it to the third, which is when it used to be back in the day. So it's going to be the 17th of December. So the calendar has it, the tentative date of the second Tuesday of December. We've moved it to the third Tuesday, Thursday. Mark that down. We will, of course, be updating you on all that as it gets closer to banquet time. I've got a bit of sad news to report. Astronomer Milton Antonek has unfortunately passed away. He was an active member of the club when I joined. He used to have a big refractor that he would take to astronomy at the beach and whatnot. His son Gary has reached out to us because his father left a substantial estate, and Gary is not an amateur astronomer and does not know the basically the relative value of all this stuff. He would like somebody in the know to help him sort it out. If you are willing to do so, and Gary said he can compensate, please reach out to me personally, president at warrenastro.org, and I will hook you up with Gary Antonek, and we can get that sorted out. If you have any fond memories of Milton for the W.A.S, please send them to publications at warrenastro.org so we can get a tribute into the next issue of the W.A.S. And in happy news, we've got the Treasury situation with Bank of America has finally been sorted out. We hooked up with the right person. We have a fully functioning treasurer in Mark Miles. He's on the account. He's got the checkbook. Yeah, he's got all rights and privileges. Everything is sorted out and legit, and we are very happy about that. However, we are still short a board member. We do not have a secretary at this time. We have been using AI. AI does the job, but it can't vote. So in the event of a tiebreaker, we really need that seventh vote.
I mean, it can probably vote.
Don't give it ideas, Jeff.
No, something very odd.
Yeah, no suffrage for AI. So, if you would like to get your feet wet as a member of the board, secretary is probably the easiest way to do it. Um, you don't have to know anything about astronomy. You don't have to know your way around a telescope. You don't have to know your way around the sky. It's all optional. You just have to be able to take notes, and we have tools to help you. So, if you'd like to join the board, see me at the break. Or send us an email, board@warrenastro.org, and say, hi, I'd like to join. And with that, I will hand things over to our first Vice President, Jonathan Cade, to tell you all about what's in store.
The calendar continues to fill up. We only have a few slots left in the year, and I'm still taking suggestions for presentations. At Macomb this month, we will have Stanford astronomer Kaylee Toke speaking to us about citizen science and working with something close to Gary Ross's heart, the AAVSO. Oh, and sorry, one thing that we do need to address, especially considering our main presenter, is that today is May the 4th, and May the 4th be with you. As Spock used to say, May the 4th be with you.
Thank you, Jonathan. Okay. Jonathan mentioned calendars. We do have one additional note that I want to bring up. It is not too early to send in your astrophotographs, your sky photographs, your various celestial photographs, your weather phenomenon photographs to our board to get on the calendar for this upcoming year. I can tell you submissions are already coming in thick and fast. So if you've got pictures, we'd love to see them. And with that, do I see? I do see Riyadh. Take it away.
Yeah, thank you, Diane. Hello, everyone. Our last regularly scheduled open house was on April 25th.
Hold on one moment, Riyadh. We're having an audio issue.
Just have
Okay.
to turn up the volume on this. Try again.
Okay, can you hear me better now?
Not yet.
Very, very close. Here we try now.
Okay, how about now?
Whoa! A little, yes, very good. Keep going.
All right, thanks.
Oh, but you don't have it over there. Okay, carry on.
Okay, now? All right, thank you. So, yeah, last open house was on April 25th. We started out about 7:30 and it was completely cloudy, so we closed the observatory at 9:45. We had still about 20 visitors, and 6 members attended. So since we couldn't observe anything, we talked about astronomy with them and telescopes and how to observe and so on. Thanks to Jeff McLeod, Tina Wong, and Dale Barton. They helped with opening the observatory and helped with the running of the open house. So next open house is scheduled for at 8 p.m. for May 23rd. Also, we just had this last Saturday an open house on May 2nd for the Scouts. It was clear, so we took advantage of that. We opened the dome. Jonathan was there helping to open and close the observatory. Diane and Alberta and Dale also were there, and they helped with the open house for the clouds, answering for the Scouts. I mean, sorry, answering questions. Jonathan also used the 22-inch reflector outside for deep sky objects. In the observatory, they look at Venus, Jupiter, a couple of double stars, Castor and Gemini, and Algebra and Leo. So thanks to everyone who helped out, a lot of people actually. We had something like maybe a total of 40 to 50 maybe scouts and parents along with us attending there. So it was really nice to finally have an open house with clear skies. So hopefully we'll see everyone at the next open house on May 25th. Thank you.
Thank you, Riyadh. Do we have Treasurer Mark Miles in the house? I know he had to run home to take care of some business. All right, Mark should be here by break time to take everybody's money if money is in the offering. In the meantime, check out the financial report in the W.A.S that was published just a few days ago. Secretary is vacant. That takes us to outreach with Jeff McLeod.
I didn't do outreach. I went to the Kennedy Space Center instead. Yeah, I got bad news for you. It's expensive now. Cranbrook went okay. I talked to Bob. It sounds like they had around 50 people come out. The weather was okay.
We had
But-
some clear spots.
You could see.
People got to see the sun.
Okay. Well, we're not in control of that. Cranbrook is so. Hey, Tina, refresh my memory. Do we have anything coming up? I don't think we have anything on the this month. So it's time to start talking about astronomy at the beach.
We do have an event coming up at Cranbrook in August.
August,
Two.
okay.
Two events.
Two in August, the daytime and night.
We'll talk about that closer to August. But astronomy at the beach is the big one. We're teaching Tina how to haul the trailer just in case. But we also want people to know how to run the telescope. So if you're at all interested in help running the big dial, helping out at one of the W.A.S tables, you can start sitting in on the black meetings. Or you can just contact me and say, hey, I'm interested, but talk to me in August because the event's in September. That's it. One last thing. Tomorrow is the anniversary of, now I need to remember, Sigma 7.
Shara?
No, I'll pull it up on my phone.
Scott Carpenter.
No, I'll pull it up on my phone. I'll get you at the observatory.
If it's Scotty Carpenter, that's exciting. Jonathan got to talk to him once. All right.
Alan Shepard. Oh yeah, Freedom 7.
Freedom 7, America's first tomorrow manned space.
61.
Wow. As far away as the club's origin. All right. I don't believe I see our publications director on tonight. She let us know that she had a conflict. So the WASP is out. If you would like to be featured in the WASP, email publications@warrenastro.org and our award-winning newsletter editor, Dale TV, will get you in there. That sums up our officer reports, but we do have a solar update, do we not, Bob?
Well, a minor one. It's a little bit busy today, so I'm going to be reading from spaceweather.com. There are about 6 unnamed sunspots. I just lost it. Oh, for crying out loud. It just went away. Spaceweather.com. You can also get the Space Weather Live app for your phone and have it tell you all about solar flares. And I'm not on the internet. Oh, for crying out loud.
Okay, we can
All
tell
right.
what sun looked like.
All right, so
Saturday.
there are 6 sunspots on the sun. There is a coronal hole that is spewing solar wind at us right now. It should be hitting us tomorrow. It said it's not really probably going to cause any auroras. The Eta Aquariids is happening right now. That is debris from Halley's Comet. So you can see that tomorrow night.
And spaceweather.com had an article about, I don't usually see sensational stuff on that site, but what their article was, are we overdue for a super flare? And apparently there's a paper, and they're discussing a new classification of solar flare, with X is currently the largest. What they're saying is that anything above X10 is now an S, or a super flare, and we're overdue for one of those. So, yay. So that's it for solar right now.
All right, so if you do have a hole in the clouds, we recommend you look because we saw lovely prominences, sunspots, and filaments in hydrogen alpha on Saturday. And that brings us to double stars. As Riyadh said, we saw some beautiful double stars at an unofficial meeting of the subgroup on Saturday. We saw Aljaba in Leo and Castor in Gemini. Riyadh, what's do you think is on the docket for May?
Yeah, so we have this symmetric eyepiece that wanted to use it, but the batteries were dead. So I'm going to have that fixed by next open house. And hopefully we'll try to do some measurements.
So, sounds like fun. All right, do we have the captain of the radio subgroup in the house tonight? I didn't see Tom, so if you are interested in joining,
Yes, he's on the call.
he's on the call. There you go. Thanks, Tom.
Yeah, I'm thinking about offering a class or mentor a group that would be interested in building individual radio telescopes for hydrogen line detection for hydrogen in the galaxy. Um, these small ones can be built for maybe $100 total budget, and you can do some really interesting things with them. There's you can measure radial velocities of hydrogen gas in the Milky Way, and one of the interesting experiments that we can recreate is to show the existence of dark matter that holds the galaxy together. It's kind of neat. I could do it online. I would probably do it online, and we could maybe get together at Stargate to troubleshoot problems and whatnot. So if there's interest, I'd like at least 2 or 3 people to get involved, to make it worth my while. And email. Let's see. Sorry, wrong slide. My email. So let me know if you're interested in building a small radio telescope. That's it.
All right.
Thank you, Tom. All right, if you are interested in being a subgroup captain of your very own Foreign Astronomical Society subgroup, let us know. In the past, we've had things like the computer subgroup, the urban observing subgroup, and the amateur telescope making subgroup. So if you are interested in being a captain of the thing that is closest to your heart, just reach out to the board. That brings us to observing reports. I believe we actually have some observing reports because we actually had at least one clear night. Who's got some observing reports?
We have one on the screen. Well, we have several on the screen.
Okay, take it away, John.
Well, I'm going to go first because I'm up here, but Dave Noble also has a more exciting observing report than mine. So I'm going to open these up and share them on the, hopefully in one window instead of all in separate windows? I guess we'll find out.
Jonathan, while the camera's not moving the person who's talking from,
No, yeah, I have to turn it up. So,
it's
am
stuck.
I
with the last
super
person
zoomed
who
in?
talks.
Thank you. All right. Yeah, so let me share this. All right. So here are some observing some through the eyepiece photos I took with my phone through the Kalinowski Kula telescope at Stargate. So this is Jupiter with 3 of its moons coming through. Callisto was on the other side and not nearly as bright as you would expect. But you can see right in the middle here, you can see the red spot, which I haven't gotten a cell phone photo of the red spot in a while. Yeah. Sorry, I'm having to. Now, keep in mind, this is still a cell phone, so, and it was not doing a time exposure, so maybe, I think you can see the red spot pretty well there. If you look right in this area. And keep in mind, the red spot is no longer a red spot. It's now a white spot with a salmon center. Kind of looks like a sushi roll. All right, and clearly things are not working the way that I want them to, so 1 second. So this is the sun as we observed it at Cranbrook. Oh, here we go. As we observed it at Cranbrook on Saturday. So you can see lots of detail on it. You can see several sunspot groups. Here's 2 here, another one here, 2 more. Filaments on the surface, over the surface, some prominences. This one we saw develop from a tiny little spike on the horizon of the sun to this giant cloud here. And then this one was going for pretty much the whole time. Bunch of active regions, just a lot going on in the sun. So if you have a solar telescope, eventually the solar cycle is going to hit its low. So don't miss the opportunities to do some good observing while you can. And one last non-astronomical observation. If you haven't been out to Stargate in a while, you may be surprised to know that we are now next to Jurassic Park. Dave, did you want to come up and talk about this amazing observation of yours? Let me switch the share to it. All right. And it's up.
Alrighty, so let me get the mic. There we go. Can you hear me? Yes. All right, so it's the Splitter Galaxy.
Oh, wait. Sorry, it's not showing the right one, it looks like.
That's what I got.
No, it's is. Oh, I see. It is. Sorry.
That's what I want to send you.
Yeah, I was.
Okay.
Go ahead.
So NGC 5907 Splitter Galaxy. I stream live on TikTok and I get some followers. I follow a couple big creators or amateur astronomers. Between the 2 of them, they have over 3 million followers, and they both came into my live. And one of them suggested computing this galaxy. He goes, "Did you get the supernova?" And I'm like, "No." He goes, "Well, why don't you try it?" So I did, and it actually came out better than I thought. And it's just with the C star S30. I don't think I shot it for more than an hour. So, but where the arrow is pointing is where the supernova is within the galaxy. So that was it. That was kind of cool. And I guess it was 50 million light years away, and it was just discovered. The supernova was just discovered last month. So
If you can have to Yeah,
It's gonna get
it's in the
blurry.
corner there
Yeah.
underneath the photos. Yeah, just click that up. I'm sorry, you have to click in the corner.
Oh, you did. There we go. So that little dot there. That's what they told me. So that was it.
What's the big white thing to the left?
It's a rift in the time.
Yeah, that's. I had the line a little too thick. Yeah, I did it really quick. So yeah, wasn't thinking of sharing it here until just now. So yeah.
Sorry, I thought.
Yeah, don't maybe come over there. I didn't think you were.
All right, it's nice to have some observing reports. Anybody else get to do any actual observing?
Go next.
You have another one, Jonathan? Yes. Okay, Jonathan's got another one.
All right. So personally, I went up to Black River in Alcona County, where the skies are still really good despite the best efforts of the townships to put in streetlights everywhere. I spent pretty much the entire evening just looking at the Sombrero Galaxy with different magnifications and different telescopes. So I would highly recommend just trying to focus on an object and trying to get as much as you can out of it.
You also saw Moline.
Well, that's right. I saw a probably minus third magnitude meteor break up into at least 10 fragments through the window of our house. So that was pretty cool. And people in Bay City saw it looking northward. So it was somewhere between Black River and Bay City. It was 2 weeks ago.
Yeah, 2 weeks ago. All right. So if that concludes observing reports, then we've got a time for a little news update. Bob, do you want to run with this one?
You have
Curiosity. Yeah, we haven't had any news updates from our Mars rovers in a while, but one came in and it was a little bit scary, but Bob will explain why it's not as bad as it sounds.
If you know.
Okay, so on YouTube is this fellow called the Mars Guy, and he posts Mars news. And apparently, the Curiosity rover, which has been drilling into rocks ever since it's landed there, found a rock to drill into and had a problem. It couldn't pull the drill out. The drill that pulled the arm up, and the whole rock came right out of the ground. So it's like they literally they tried shaking it, they tried putting it sideways, like get off, get off, get off, get off. Eventually, it was held sideways, and between a 15-minute window, it had fallen off and broken on the ground. So, but the way, and there are replacement drill bits on the rover, which I did not know. So that's pretty cool. So
Drill bit?
yeah, but apparently there's a problem on either side of the drill bit are these two things that stick down and they like stabilize the drill bit. That stopped working, so they had to pull those up, and they're actually just using the rover to like jam the drill bit down, and it's causing the hole to go around. So that could be why it got stuck. But so anyway, I wonder if they're going to look at that rock because there it is split open in front of the rover now. That's pretty cool.
All right. So I don't see David leading on for his poetry corner. But we are getting to the bottom of the hour, which means it's time for me to hand things over to our first vice president to introduce our speaker for the short talk.
All right, let's pull up the presentation for the short talk as well. It'll look a lot better.
One on the desktop.
The one on the desktop.
The one on the desktop is brand new.
Okay, I got the one earlier this afternoon, but
Okay.
all right. Tonight we are going to be hearing a short presentation by Gregory Frederick. Gregory is a retired mechanical engineer with 3 degrees, a master's in mechanical engineering from U of M, a bachelor's in mechanical engineering from my alma mater, LTU, and an associate's degree from MCCC. Gregory has principally worked in computer-aided engineering, doing structural analysis of vehicles with finite element analysis. He used some of the same software that NASA uses to do structural analysis of their spacecraft and Mars robots. He visited NASA Langley when he was training in various CAE computer programs. Greg has had a lifelong interest in both the manned and unmanned space programs and in cosmology and astronomy in general. He is also a docent at Cranbrook and at the Selfridge Air Museum, and he and his wife Ella live in Shelby Township. They've been members of the W.A.S for a long time, so thank you for presenting to us, and come on. Sorry.
That's okay. Okay, so I was going to talk about future lunar missions that are coming up in the next few years. Uh, but initially, I wanted to just remind everybody, and I bet everybody remembers, about the 6 Apollo missions that successfully landed on the moon from the late 60s to the early 70s. I personally watched all those missions, by the way. But no one else has been on the moon. Those 12 astronauts were the only ones ever to set foot on the moon. Russia never succeeded.
Advance the slides.
Oh, okay. Russia never succeeded. They had what's called an N1 rocket, but every time they launched it, it blew up. So,
Wait a second. Why did it advance there and not here?
I don't know.
Sorry, we're
technical difficulties.
doing something funny here.
Sorry.
Yeah, you can.
Oh, it's not shared. Oh. Are there 2? Oh. The wrong way. Yeah, we're gonna have to start bringing the mouse. Yeah, because we lost Jim last year. Service. So when can I again? Yeah. I don't know why it wasn't doing that.
Yeah. So,
Oh, sorry. Hang on, people on Zoom. We'll get to you eventually. All right. Let's throw the title slide back on there just for their benefit for a second.
Okay. Constellation was like.
Did it lose the?
Budgetary.
Okay, try it again.
Should it go back or forward?
Okay.
Okay. All right. So starting off again.
And then try to look into that.
Okay. So starting off, just a quick look at the past. Like I said, 12 astronauts have been on the moon. No one since then. Russia did land robots on the moon, but never cosmonauts. Okay, so what I want to talk about here is comparison of the hardware that's going to be involved. And to reiterate, back in Apollo, it was a space race between the Soviet Union and the United States. And it was principally, I would summarize a competition of who had the better governmental system, who could do the best and most amazing things. And John F. Kennedy set a goal for us to get to the moon before the end of the decade, before the end of the 60s, which they did. And now, though, we're in a race with the United States, NASA, and partners from Europe and such against China. And in this case, yeah, there's also bragging rights being involved, but I think a lot of this is being driven by commercialization and utilization of the moon's resources. Because by 2030, China plans to be on the moon and eventually setting up a permanent presence at the South Pole. NASA wants to do that too. They want to get there before the Chinese. Chinese would be using this Long March 10 rocket with booster rockets on the side, I should say, and we have, which was already used in Artemis 2, the SLS, which is Space Launch System Block 1. Now, both of them can put about, well, in China's case, 70 metric tons into space, and the Space Launch System could do 95 metric tons into space. But what's really more important in a way is looking at what they can launch to the moon. And on the left side of the slide, you see that the SLS Block 1 could do about 26 metric tons launched to the moon, and Long March about the same thing, 27 metric tons. And I'm showing in comparison the old Saturn V and the Falcon Heavy for comparison. But basically, the Long March 10 and the SLS Block 1 are only meant to launch a space capsule and crew. You need a separate launch if you want to put a lunar lander out in space, basically launched to the moon. Because what they're going to do, at least the current plans from China and the United States, NASA, is to rendezvous with a lander in lunar orbit, which is not what Apollo did. They rendezvoused in Earth orbit. But this is going to be changed up in the future here. Now, what I'm showing here is what was the SLS evolving. And this is not going to happen, this evolution. Jared Isaacman basically said, we're going to have a Block 1, which you see on the left, which launched those 4 astronauts, and we're not going to do a Block 1 cargo or a Block 1B. None of that's going to happen. He's trying to keep pretty much the same configuration. There will be a change in the upper stage of the Block 1, but generally it's going to be about the same thing as you see on the slides right there, the left. Because he wants a faster cadence, he wants to reduce complexity, and he wants to reduce costs. And if you evolve it like this initial plan was, you're going to really up the costs. Okay, on this slide, I'm showing you what the potential lunar landers will look like compared to the LEM Apollo lander. SpaceX has their human landing system, which is huge. It's 50 meters high. And Blue Origin has 2 landers. They have a Blue Moon Mark 1 and a Blue Moon Mark 2. The Mark 1 is a robotic vehicle that would basically just take cargo to the moon. The Mark II is a human-rated vehicle. Okay, now one of the problems you probably can see right away with the SpaceX vehicle is it could easily be very likely to topple over. Because when you expend a lot of fuel, all the weight, all the mass, or most of the mass is
in the upper part of the space vehicle, because that's where the crew and the cargo is. So if your center of gravity is rather high, which it'll be in this vehicle, and your footprint is rather small, all that CG has to do is get outside that footprint up for a little bit, and it'll topple over. And the moon isn't exactly a flat place to land on, without debris and stuff to worry about. Okay, here is a slide showing basically a close-up of Blue Origin lunar landers. Like I mentioned, the Mark I is robotic. The Mark II is a human-rated vehicle. And actually, right now, I believe NASA has a Mark I being tested in Florida currently. I don't know that they have anything like a Mark II built up yet. But if we want to get to the moon before the Chinese, they got to really move fast because we don't have a land right now. Okay, on this slide, I'm showing what was the initial plan of how we would get to the moon before Jarek Eisman came in and shook everything up. The red ellipse there is showing the near rectilinear halo orbit, which is what they were going to do before Isaacman came in. That red ellipse shows the orbit of what would have been called the Gateway, a mini space station that would have orbited the moon, and the Orion would rendezvous with that, and then there would be a lander attached to that Gateway space station, and then you would, put astronauts onto the moon. But that's all gone now. They're not going to do that. Again, they're going to try and save costs and move things along quicker because of the competition with China. So they're not going to do, at least right now, they're not going to do a gateway. Here is a iris representation of China's Lanyu human moon lander. And as far as I know, China is pretty much hitting all their critical targets in their path to get to the moon by 2030. They have vehicles built, they're testing vehicles, uh, and I don't know of any problems that they've ever had yet. That's the Lanyu on the left. And what they're doing there is simulating a moon landing by, holding the vehicle up so it does 1/6 Earth gravity simulation. And that's a picture comparing it to the LEM. Here's the spacecraft that they would use, China's Manju spacecraft and NASA's Orion spacecraft. Now, some differences between them. Basically, the Manchu spacecraft could carry up to 7. I guess in China they call them takinauts, but I'm going to call them astronauts for sake of clarity here. Could carry up to 7 into low Earth orbit, but for deep space missions, they would have 3 or 4. NASA's Orion spacecraft can carry 4, as you probably noted in the recent mission, and they can be in space for up to 22 days, going to the moon and beyond the moon somewhat, like they did with the Artemis 2 mission. It consists of a crew module and European service module that has solar power, advanced heat shielding, and it can carry 4, like I said, 4 astronauts, but 2 would land. Here's the diagram of the Orion, showing the European service module built by the ESA, European Space Agency, with its extended, I don't know what happened there. Oh, okay. It's back.
I was told there's a storm moving in, so there's a non-zero possibility that we could lose power.
Oh, okay. All right, getting to the Artemis SLS rocket. Interesting things been going on with that. Like I said, Isaacman wants to keep the Block 1 or near Block 1 configuration to reduce costs. They were originally, see, the upper stage, which is called the interim cryogenic propulsion stage, on the left, well, I don't have a picture of it there, but they only have 3 of those vehicles left, 3 of those upper stages. One was used in Artemis 2. So they got one for Artemis 3 and one for Artemis 4. After that, they don't have an upper stage for the SLS because originally the ICPS was built for the Delta Heavy rocket, and that's out of production, and so is its upper stage out of production. So after they use up the next two ICPS upper stages, they don't have an upper stage unless they do what they're planning on doing now, which is using the Centaur 5 that you see upper right as an upper stage. They were going to build the exploration upper stage, which you see on the left. It was a much bigger, beefier, more powerful upper stage. It was being built by Boeing. And of course, it was seeing a lot of cost overruns and being delayed and whatever. So Isaac Min said, no, we're not going to use that. We're going to use something that's already being used on other rockets. It's proven, it's reliable, and it uses the same type of fuel. Oops.
Is that a cable thing? Or?
I don't. It just interim goes up and down. Maybe. Okay. So like I said, they're not going to build this exploration upper stage. They're going to keep a near Block 1 configuration by using the Centaur 5, which is proven. Now, how do we get a lander to the moon? Well, if it's going to be, there's a competition between SpaceX and Blue Origin. Whoever can build a lander faster and get it on time for us to get to the moon before China gets the money to do it. They get that contract. So if it's going to be Blue Origin, they would use a New Glenn rocket with an upper stage and launch the Blue Moon lander to the moon and then rendezvous with the Orion space capsule. If it's SpaceX, they'll use their giant HLS human landing system to get to the moon. But the problem that SpaceX has is you can't just launch it directly from Earth orbit to the moon. It has to go to a refueling, I'll call it gas station, orbiting the Earth to be fueled up. And to fuel up the gas station, you need possibly 10 SpaceX launches to fuel up this orbiting gas station. And then the upper stage of the SpaceX's vehicle would have to mate to the gas station and fuel up. And no one's ever done this in Earth orbit. No one's ever refueled huge amounts of cryogenic fuel in space. What could possibly go wrong? Everything. And so that's another hurdle for SpaceX. Okay. Now, here's a picture showing hypothetically what refueling would look like for the SpaceX HLS in space. And another idea that came from SpaceX was they said, well, you know what? Maybe we could use the upper stage, our HLS lander, if it's fueled up, to also use it as a space tug to ferry the Orion space capsule to the moon. That's what I'm showing on the right here. Now, here's Artemis' new timeline, okay? We already had this year in 2026, Artemis 2 doing the flyby of the moon with a free return. In 27, next year, the goal is to do a launch, but not to go to the moon, but to go to Earth orbit and to rendezvous with either Blue Origin's lander or SpaceX's lander, whoever has one available. And if they both have them available, they want to do rendezvous with both of them to see if they work and to see how well this rendezvous technique works. Do it in Earth orbit, it's safer than doing it at the moon when you're testing. Then in 28, they'll go to the moon and land. If we have a lander, if SpaceX or Blue Origin has a lander. Then in late, that's early 2028, and in late 2028, they want to go back to the moon. And this time they would use the Centaur 5 as the upper stage because they've run out of ICPS upper stages. So it's a lot of ifs, but that's the plan. The Long March 10 rocket specs, I mentioned it can carry 70 tons of low Earth orbit, 27 as the translunar injection trajectory. You can do missions that have 3 or 4 astronauts if you want to go to the moon. And they would land 2 astronauts like we would land on the moon too, 2 astronauts. The Long March 10 is a little different than you might think. It doesn't have legs. The goal is not to have any legs on it because what they want to do is catch it on a sea barge in a weird kind of contraption. It's similar to what SpaceX does, but they want to recover it using this, a series of cables that will capture the booster stage, and it has no legs. And no legs because it reduces weight, it reduces complexity, and they want to do a fast turnaround of their rocket, multiple rocket launches a year to establish their lunar base at the South Pole. Now, here's the future NASA potential future plans for a moon base. Phase 1 would use robotic vehicles. There are robotic vehicles on their way to the moon this year too, to do some initial infrastructure work and maybe some scouting of the terrain and resources. And in phase 2, they want to do a long duration human presence on the moon. They say similar to what we do at the International Space Station. You send a crew up for a certain amount of time, then maybe later on you send another crew up. And then in phase 3, by 2036, they want a permanent presence on the moon, including using resources on the moon like oxygen and water pulled from the bottom of craters where frozen water ice is sitting, which is why they want to go to the South Pole. And that's about it. This is a picture, though, showing the picture that the Artemis 2 astronauts took when they were getting near the moon or on the other side of the moon of the Earth. And just one thing to note, they actually went further in space than the Apollo 13 crew did in 1970 by 4,100 miles. So they set a new record. So, any questions?
Yeah,
Yeah.
I'm so doggone old. I remember when Al Shepard went up. What is all this business about beating the Chinese? By treaty, no one can claim the moon.
True.
So what? Are they trying to turn this into some kind of a circus where let's see who comes in first, who comes in second?
I don't know, but all I know is this is driving it. This is what's driving it. If China wasn't doing this, we probably would be much slower pace to get to the moon. I mean, why do they want to do a mission in 27 and 28? I haven't seen this since when I was a kid watching Gemini missions or Apollo missions. They're increasing the cadence because they're competing. Like we competed in the 60s against the Soviet Union.
Well, maybe it's good then.
Yeah, Jonathan.
So I think one of the reasons that people are concerned about China getting a long head start on the South Pole is that the thought is that there are a lot of hydrogen-3 deposits there, and if China finds the best deposits and there, some area that is easier to mine that, and that's what you would use to make fuel, of course.
Yes.
Then you have a problem if you ever want to do anything there. So, so that's the urgency behind it. I didn't have a question, but I'll let somebody else go.
Yeah, there's a lot of there's hydrogen-3, helium-3, there's uranium, there's rare earth elements. Yeah, and water. Water is very, very important. It's heavy, and the moon's got quite a bit. Yeah, yeah, Jeff.
I'm just a bit of a pessimist. Is there anything you can say to me that would increase my odds of this happening from 0 to a positive number? Because this is insane. Do they have a contingency when both SpaceX and Blue Origin don't have a
Not that
lander
I
next
know
year?
of. No, not that I know of.
I don't see it happening.
China, like I said, they don't have any oops or gaps in their path, their trajectory to get to the moon.
Well, it looks like they're going much simpler than we.
Now, yeah,
Okay. So I have a presentation that I've given over the years about why the Soviet Union failed to reach the moon. And instrumental in their failure to reach the moon was instead of having one rocket, one crew, lander, one plan, one streamlined goal, they had multiple goals, multiple lunar landers, multiple satellites, and multiple bureaus. What is this? I don't think any of this is going to happen. Because it didn't happen the last time somebody tried.
Certainly not by 2030.
What, no, and a limited number of rockets, all of which went boom. After which there were no more rockets. So Artemis 2 was fantastic, but the rest of this just sounds fanciful.
Yeah, and it's actually it killed a lot of scientists this year.
oh yeah, when an N1 blew up in Russia, they used to be around the pad, and it exterminated a lot of the personnel.
It's extremely amusing, isn't it?
Yeah,
So for, the long-term thought for the major challenge of long-term lunar habitation, if we get there by 2032 or 2036, has been the fact that the ISS is fine because it's in low Earth orbit and it's protected by the Earth's magnetic field. The south pole of the moon doesn't necessarily have a magnetic, it has a little bit of magnetic field residual, but I don't know if that's enough to really protect people.
no,
So what is the plan there?
they would have a problem because in Apollo days they were there about 3 days. It was a weekend visit. But if you want a permanent presence, then yeah, you got to deal with solar radiation and cosmic radiation. And I don't know that they have. The only thing I've ever heard of is they would pile on a lot of regolith on habitat. And actually, on the International Space Station, they did test a vest that an astronaut could wear that would prevent radiation from impacting, your major organs. But other than that,
Your head.
yeah, well, that's got to be protected too. Yeah, yeah, yes.
It seems to me that getting materials from the moon, be it uranium or rare earths or anything, is increasing the cost of getting that material more than sky high. Shall we say moon high?
Yeah, yeah. Well,
You can only use it in space.
it could be used in some way in the future on the moon itself, but getting things back from the moon to the Earth, yes, that increases the cost, of course. But the thing is, I see China is going there because they're planning on doing resource use of the moon, using its resources. So that's their plan anyway. How they deal with the manufacturing, whatever, I don't know.
We have time for one more question.
Yeah.
My understanding is that often astronauts get like a space sickness if they're, someone doing and being out of the moon with one big gravity.
Yeah.
How would that affect how long or the human functioning?
Well, I'm not an expert on that, but I would say that we have evolved in 1G. And when you don't have 1G, you're going to have some problems. Probably the longer you're there, the more muscle loss, bone loss. Crew members in the ISS have lost bone material, muscle loss, fluid buildup in certain areas, like the eye, for example. I think that one astronaut who was in the International Space Station who has a twin brother, I forget his name.
Scott and Mark Kelly.
Yeah, when he came back, the two twins stood next together. He was shorter. So there's definite changes that go on when yeah, the moon would give you 1/6, but that's not how we evolve.
One astronaut from working on the surface of the moon, he only made it to his 50s. So that we know that the moon can kill you.
Space is unfriendly. Nobody hears you scream in space. Okay, anything else?
All right, it's time for our 15-minute snack break. Again, Parker and Ruth Humantle brought wonderful snacks. So dig in, everybody. We'll reconvene in 15 minutes with our future presentation.
I delivered. Get the next presentation or set up so we don't have a delay. So here can be that We will be beginning very shortly. Do we still sound good on the Zoom? Good. It's just wait.
Oh, yeah. Randy. And every running and they or you want to do your own theater. Easy, like God, our clubs. Wow. Almost make me want to be observatory chairman. Hey. But it makes me want. I heard. So that's wrong.
Gyre.
Yeah.
You ready, Gary? Yes. Is this your chip? Oh, yeah.
All right. I think we are in a position for me to once again turn the reins over to our first Vice President, Jonathan Cave, to introduce tonight's featured speaker. Come on down, Jonathan.
Down, up, no other thing. We have there are coordinate systems for space.
Yeah.
Suicide. No, I'm not walking favorite about no, thanks for the
All right, Hughes. Are we clear on the presentation on the Zoom?
Yeah.
All right. Gary Michael Ross was for many years the greatest observer in Michigan, now retired. First observations 1958 with father's binoculars. In the aughts, he was known as the third greatest first vice president in W.A.S history. Currently, and for over 50 years, he is a member of the Grand Rapids Amateur Astronomical Association, also known as GRA. Ladies and gentlemen, the man, the myth, the legend, Gary Ross.
For those of you who know Greek, eke homo.
That's Latin.
Oh, that's right. That's Latin. That's why I didn't understand it. Now, where do I press?
You can just use this arrow.
The arrow. All right. The genesis of this lecture comes out of two things. In terms of venerability, in 1960, my parents gave me a real astronomy book. This was, well, what is this with you?
Oh, is this yours?
Yes.
Oh, sorry.
Okay. Gave me a real astronomy textbook, not some kid's thing. It was Duncan's Astronomy, 1954 edition. And I was so impressed by this that I had a real astronomy book that college students used that I was determined to read it cover to cover. Well, that didn't last very long. And I probably did not get one quarter of the way through. Dr. Duncan, who went through, he had several editions of his book. I've got the 1920 edition of Duncan's Astronomy. And he had in his one of his chapters, he had pictures of the way Polaris is or rather, I should say, the North Celestial Pole is coming in toward Polaris. There was a picture taken by him in 1970. Both of them were from Lick Observatory. Duncan in 1970 and Chappell in 1941. And it was fascinating to my adolescent brain, and it's still fascinating to my geriatric brain to see how much the position of Polaris changed in those very few decades. The other thing that ignited this, and credit where it is due, is this. This is the Yearbook of Astronomy 2026, and it is the rough equivalent of the Canadian Observer's Handbook, except this is British. It's a different kind of periodical. And one of the articles in this, feature articles, was by Lynn Stockman, in which she showed the path in the southern hemisphere of how the pole stars were going to change through the millennia. And I'd never seen a chart like that for the southern hemisphere. It's a small scale chart. I mean, look at the format of the book. But I'd never seen anything like it, although I'm sure that there's no great discovery and it's in the astronomical literature. And I was fascinated to do a deeper study of which stars were going to be the southern pole stars at what point in history. And so, what better venue to launch this in but the Warren Astronomical Society, right? Where I could revisit my days of glory before mental and physical decline. That I was the only one in the history of the W.A.S. to break into a Dean Martin song. It's a warm-up act. And they just loved it. Of course, small minds, small amusements. So on the X, right? Jonathan, on the X.
Yeah, the left or the right?
It's not an X. All right, so to advance, I go to the right arrow, right?
Yes.
I just love how compact this all is. You know, I've got a fairly small hand for a man. What are you doing?
There we go.
I can do it.
Just making sure. Keep
Yeah, I now that I see it, and I didn't see an X. Is that all right? That's the title side there. The Earth, as she revolves in space around the sun, does not do so in a vacuum. I mean, figuratively. All right, this has got to get better. So one of the influences on the Earth and the position of the Earth in her place in the solar system, rather the orbit. The primary exemplar is the sun. The the sun's mass is 332,900 times that of the Earth. So the sun is the primary determinant of the orientation and I would say, the aspect of the Earth to the stars and to the other planets. The other second most influential on the Earth, is the moon. The moon is, however, only 0.012 the mass of the Earth. Now, 0.012 of our mass is very small, but it is non-zero. And the moon goes around us every 27 days using sidereal reckoning. The Earth, what does all this have to do with the Earth? The Earth is not round, or rather spherical. The Earth is an oblate spheroid. In other words, the equatorial diameter is some distance greater than the polar diameter. The Earth's oblateness is, right now, I'm going to work through this slowly. The polar diameter and the equatorial diameter, the Earth's oblateness is 0.0034. Now that's pretty small oblateness, but it is not nothing. You have a bulge at the Earth's equator, which essentially acts as a gravitational handle by other bodies around her. Now, the mass of Jupiter is truly tremendous. The mass of Jupiter is 318 times the mass of the Earth. One could say, well, 318 times, but Jupiter is extremely far away. And it is extremely far away, but not all that far. When Jupiter, Earth, and Mars are when Jupiter, Earth, and the Sun are lined up, in other words, when Jupiter is out in opposition, he is only 4 astronomical units away from us. That is more or less 600 million kilometers. 1 astronomical unit being 150 million clicks. So for such a massive planet of 318 times our mass, that is quote unquote only 600 million kilometers spaceward from us, adds up. As we approach Jupiter, Jupiter pulls on us. Remember, we are going a 1 year revolution. Jupiter takes 9.5. So we catch up to Jupiter and pass Jupiter. And as we are approaching Jupiter's position, he is pulling on us. And as we pass Jupiter's position, he is pulling on us in the other direction. There is also Venus. Now, I am not by any means a solar system physicist, but it has occurred to me, I got it up here, or used to, that Venus should have some kind of effect on us. She has a mass of 0.82 of the Earth. And I'm sure, by the way, to be fair, to come down off my high horse, this is all in the literature somewhere, and maybe 7 or 8 times through 300 years of computations of solar system position. The mass of Venus is 0.82 of the Earth, and very nearly our diameter. Now, I am old enough to remember when Venus was referred to as Earth's sister. That is one hell of a sister, because it's not a benign place, but in terms of the physics of it, it's not a benign place. Strike that for the record. It is a bloody hellhole. So it's only Earth's twin in terms of size and mass. And when the three of us are lined up, or in other words, when Venus is at inferior conjunction, it's only working from memory, maybe okay, kilometers, maybe 50 million kilometers from us in the direction of the sun. So the effect of Venus on the Earth is very small, but it's not zero. And given enough, not millennia, but millennia times this exponent of what, all of these forces gang up on the Earth's oblate equator, slightly it is as it is, to change the position of the Earth's orbit. And then I encountered this in some place in this research. There's also the galactic center. I am not going to attempt me estimating the mass of the galactic center. The figure for this probably goes up and down with more observation and more theoretical work. But it was fascinating to read that the galactic center, as extremely small as that number must be, still has an effect on Earth's position relative to the pole stars or the orientation of the Earth's axis. The moon of the Earth does not revolve around us at the equator. She occupies the plane of the ecliptic. And the moon's orbit around us can vary from 18 to 29 degrees relative to the equator. Sometimes the moon is above the equator, sometimes the moon is below the equator, and even though the moon's mass is 1/81st that of the Earth, she is a close celestial body. So the Earth's oblateness is a major factor in all of this, along with her astronomical companions. This is a rather spare drawing of what we call in this lecture the Great Gyre. I've also seen it as the Great Year. And you'll see at the top of the circle, that is the path described by where the Earth's axis points. Now, this diagram shows the northern hemisphere. I think it would have been nice if they had also shown the gyration of the southern hemisphere. And, excuse me, and the Great Gyre is often cited in textbooks as either 26,000 years or 25,800 years. The Great Gyre, as the Earth's axis points at different parts of the celestial sphere, both north and south. The Great Gyre is actually 25,770 years for the axis to move around, as the diagram shows, from one point where the poles are pointing completely around the top of the celestial sphere. The diameter of that cap that you see, the diameter of that cap is 47 degrees. It's a pretty big part of the sky. And there are a lot of stars in the path of the Earth's axis as it goes around the northern and southern celestial hemispheres. But the great gyre, to repeat, or the great year, is 25,770 years. Now, this is a question. I'm not trying to trap you. Well, if I'm trying to humiliate someone or make someone look foolish, then I have no business at this podium. The great year is 25,770 years. The biggest other measure of time and cosmic time I can think of is the cosmic year, the time for the solar system to go around the galactic center, which in the most recent estimate is approximately 220 million years. Between the great year of the gyre and the cosmic year, can anybody here tell me if there's any other measurement of cosmic time as some sort of standard metric? Has anybody ever heard of something between 26,000 years and 220 million years? Do I see a hand? Oh, there's a hand.
Well, for example, the eccentricity of the Earth's orbit around the sun varies.
Yeah. Right. Yeah.
I think we just said that's on the order of 100,000 years.
All right. Yeah. Yes. Yes.
I have one slightly bigger. So, as Gary mentioned, Jupiter and Venus can influence, because Venus gets as close as 24 million miles. The scientists have found very strong suggestions of a 400,000 year cycle where Jupiter and Venus pull on us and can actually have significant climate changes.
Oh, yeah. Is that the Milankovitch or what cycle you're talking about?
I don't recall the name. I just vaguely remember it's a
400,000 year
Yeah.
timepiece. And Dr. Pardon, what did you say?
The eccentricity
Changes.
changes cyclically. I think it's 105,000 years that it goes back and forth a little bit.
All right. Well, I appreciate the counsel, but it's a little oblique. Your answer is a little oblique to my question, in that one refers to the great year as pro forma, and of course, to a much lesser degree, people refer to the cosmic year. But the cycles that you are describing don't seem to have a name. I'm not saying they don't exist, but there's no nomenclature. If you can follow me, they don't. People don't say, well, this cycle or that. You're 105,000 or whatever. You're 400,000. It's not routinely referred to as a cosmic measure. Yeah, I know it exists. Fine. Well, maybe this is all just razzmatazz and advertising. I don't know. In other words, if it doesn't have a name, it cannot possibly exist, right? Anyway, that was attempted humor. So I thank you both for that insight. This is a roll call of the Northern Hemisphere stars that have acted as a pole star in the Northern Hemisphere over the millennia. Now, there was no attempt here to rank their importance, of course, but these in the great year. Now, please understand, I'm measuring this often times from rather small scale charts. But through all the cosmic year of 25,800 years. In the northern hemisphere, this is a representation of those stars of varying magnitudes, which is served as the pole star. It is worth mentioning, in fact, more than a little, that the first listed Alpha Ursa Minoris is also known as Polaris. Now, Polaris, as an aside, is a low amplitude Cepheid variable. And in 2022, it was 89 degrees and 15 minutes of declination, which means it's just a hair short of being on the pole itself, is Polaris. Stella Polaris was the name in the Middle Ages and in medieval times. And Pytheas, it is Pytheas, noted of the northern sky around the celestial pole. This was around 320 BCE, that the polar area of the celestial sphere in the north was, quote, a void. There was just nothing there in the 4th century BCE. Frisius measured in 1547 that the difference between the North Celestial Pole and the position of Polaris was 3 minutes and 8 minutes. 3 minutes and 8 minutes of arc. Now he's working in the mid 16th century, and he must have been a very good observer, because he got it down to something like the nearest minute of arc. He must have been using equipment similar to Tycho Brahe about maybe 40 years later. But one has to give him points for attempting such an observation. And Polaris, our pole star, is 2.2 magnitude visual and is thought to lie at 450 light years away. In the 24th of March, 2100 will be the closest approach of Polaris to the true celestial pole. I'm going to say this again. The 24th of March in 2100, that is the closest approach. So the star is closing. I have to, because it seems like the star is moving, the star is not. The Earth's axis is moving, and will top it off at 1,629 seconds. And then after that, the North Celestial Pole and Polaris will separate. The last time Polaris served as our pole star was in the year 23,600 BCE. So it's coming back to its glory, and it will come back again. All right. Here are the stars, which, by my reckoning, my imperfect reckoning, because, to repeat, I'm not using any sort of astrometric program. I'm scaling off maps. There's an arc or a circle, and I'm scaling these off, well, frankly, with a ruler, and making these estimates. And these are the history of the South Celestial stars. And Alpha Hydrae believe it or not, if one knows the position of the constellation Hydra, is a pole star. Take a look at the position of the constellation of Hydra. I brought down two charts here showing the north and south polar regions, and Alpha Hydrae is so far down south that it's not on these charts. So the pole can move methodically, of course. This is not some random motion, can move very far from the existing north and south celestial poles. I mean, the stars can vary. I have to be careful. I'm talking on relative terms. And it seems like the star is moving. The star is not moving. It's the celestial north or south pole which is moving. All right. A little statistics. My old advisor said, if you can't put numbers to it, it's not science. Which strikes me as a little stuffy, but he got me a degree. These are the Harvard classifications of solar spectrum. I do not know, but should know, when the researchers at Harvard formulated this scale. I know that what you see before you is a major revision from the original Harvard classification based upon temperature, spectra, and the brightest and hottest. The most inferno-like is class O. And then we move down the line and the spectra change. Did that just fade? No. All right. And the spectra change, and we get, you didn't fade? No. Oh, all right. So, in what is my N here? 23, 25, I think. Out of this field of stars, that the silverware just disappeared. Anything that's not nailed down. So think of O as bright, hot, and very short-lived. And the C star at the bottom, that's the dim red carbon star. The powers that be have renamed. This is just a cheap play for attention. I know it is. Didn't your parents give you enough attention?
No, but that's
Yeah.
beyond.
Well, I do not doubt they did not give you enough attention. Anyway, thank you for your ministrations, whatever the devil you did down here. Right? If this thing blows up on me, then we will duly file suit. So moving right along. Of the N of 25 stars that I was able to extract these classifications, notice, yeah, real man of science would give you a histogram, but I don't need those stinking histograms because it's all there. It's just a horseback examination of how many stars belong to what classification. What I find amazing, but then small minds, small amusements, is that this is a camelback. If one made a histogram, there would be this void right in the middle of the distribution. And lo and behold, sweet Jesus and great balls of fire, the G class doesn't show up in these 25 stars. Well, maybe the research, my sources are dated. There's no doubt about that. But G is missing. And voila, that's what we are. That's what our sun is. A G class sun, sort of a middle of the road. The stars above G are hot, have different spectra, and below G, they're dimmer, cooler, and have different spectra. But stars like our sun do not make the cut. There is no way, with certainly my knowledge of stellar evolution or astrophysics, I could have predicted such a thing. And I was really amazed when this came up. Uh, but keeping in mind this is 25 stars that are from both hemispheres. It's an amalgamation. Something's going on that somebody ought to know about. All right, we're going to work on some magnitudes here of all these stars. Well, my paperwork is missing.
Is it down here? Is it down here?
No, don't go through that rat's nest. No, please don't do it. It's not. It's too much trouble, John. So, averaging out the all the stars that the visual magnitudes an n of 29 come out after the division to 2.8. So that is the average of both hemispheres' pole stars is 2.8, which is not a very impressive magnitude, but it's not vanishingly small either. A 2.8 star is easily visible even in, well, the city. So you say, define the city. I'm not talking about Central Park, but let's say in a place like the outer parts of the conurbation of Detroit. But this is not uh, a great help to navigation in many cases, or actually in a lot of cases. The absolute magnitudes, this is the magnitude of a star at 1 parsec, which is 3.3 light years. The absolute magnitudes, and this time my n is 30, I had more stars to work with, is negative 1.2, which is pretty darn bright if it's at 3 to 4 light years. But it is not very bright at all if at some great distance, and then it comes in as one of these 2.8, with a number that is 2.8. This is motion, both of approach and receding. This time the n is 28, and the mean after the division is 1.3 positive approach, 1.3 kilometers per second. Only 1.3. I was expecting some greater number, either positive or negative, but on the other hand, our neighboring stars are traveling with us. Now, our neighboring stars are not coming from the quote near solar neighborhood, which is 50 light years. They're all over the place. Some of them are very distant. But the motion of the sun, and hence the earth, to these 28 stars washes out, which, well, it makes all kinds of sense when one thinks about it. But after the punching in the numbers and then doing the division, it was something of a surprise. In fact, when I looked at the results field, I thought that I had made some kind of an arithmetic mistake, but there it is. So we are moving around the galactic core with this cohort of stars, which are neither outpacing us nor coming toward us. with an n of 22, the distance of the light in light years, as you can see, is 549 light years. Remember, I said these stars are not part of the near solar neighborhood, which is only 50 light years away from us. So most of these stars are at some considerable distance. 549 light years is nothing to sneeze at. But this is some indication of how even very bright stars can be rather dim at great distances. But when one needs a pole star, or at least would like to have one, it's nice to know that as dim as some of them may be, Polaris being, well, rather an exception, that this is what their distances are, and 540 some light years is not deep into the galaxy. We're in the Orion arm. But there it is, with an n of 22. They average out to 549 light years. As far as the eye can see. So, come, let us go to the very distant future. It is the year 12,900 CE. And we're in Ionia County, which is somewhat to the east of where the Ross place is, on old U.S. 16. And it's very flat there. A lot of large field croppings. And it's on a summer night. And you look south, 14,900 CE. And there is Orion, in the meridian, as a summer constellation. However, Orion has been displaced more than 20 degrees. And so Lepus, which is below Orion, is partly below the horizon. And the lower stars in the asterism of Orion, which is Rigel and Saiph, are very low. And that's what a summer night will look like with Orion crossing meridian. On the other hand, we're moving backwards. It is the year 3000 BCE. What was going on 3000 BCE? The Egyptians were hard at work. The Chinese were hard at work. The Sumerians, question mark, I'm asking. 3000 BCE. And you are on the plain of Abraham in Ville de Quebec. And the St. Lawrence is pretty wide at that point, very wide. Or if one prefers, the Fleuve Saint Laurent. And what is above the horizon of Quebec? The Southern Cross. Believe it or not. And Duncan, in his astronomy book, makes a mention of being able to see the Southern Cross thousands of years in the past in the country north of Quebec. That's what precession can do, which affects the polar alignment of the North and South poles to bring the Southern Cross, which is that hallowed asterism, or if you prefer, constellation, above the southern horizon in Canada, and how the archetypical winter constellation of Orion will be a summer sight, crossing the meridian. I would say that Rigel, just working from memory, Rigel might be 15 degrees above horizon. So that's what the changing great gyre or the great year does to what we can see on Earth. And I saw this demonstrated at the Fernbank Planetarium in Atlanta it's over 50 years ago. And so the planetarium director, using the music, the music of pictures at an exhibition, he brought up the lights in the east, the planetarium, and there was the Southern Cross from Quebec. And he said, whatever they speak in that distant past amongst the Algonquins, I bid you good morning. So, all right, you do whatever you have to this stage.
Gary, are you willing to take questions?
No, but I'll do it. It's the job description.
Sure.
Yes, yes, right. This is called Flack from the Fools. All right, what do you got on your mind?
Jeff, is it just not a question, but can I ask for a follow-up study? You've compiled a lot of information on the pole stars, both north and south. I'm worried you might have missed a statistic. I'd like to know the average proper motion of all of
Oh,
these.
boy, you Yankee.
Well, it seems to me you could say something about the pole stars of a cycle or two in the past or future, but at a certain point, these proper motions are going to start to become a problem for predicting the pole star of.
Oh, no, I get it. And I did, one source I use is the Atlas catalog from Antonin Bechvar. And he had those data. But I said, there's some certain things I don't want to know. But no, you're entirely right because when Polaris comes around and is our pole star again, Polaris will have moved.
Correct.
You're implying that, and you're not implying that. You're saying that, and that's perfectly true. Perfectly true. So if one is going to do some sort of I don't know, planetarium display of what things are going to look like a million years from now, got to take all that into consideration, and that's pretty high cut for me anyway. So maybe having neglected this, I'm going to do a roll call of the stars. This is the northern hemisphere. Alpha Ursa Minoris is Polaris, and the dates I'm giving is when the star was or will be the gold star. Thank you, Jonathan. Alpha Ursa Minoris Polaris, 25,600 BCE, and again at 27,800 CE. Gamma Cephei, no data. Alpha Draconis, Thuban, was 2,800 BCE. Tau Herculis, it was at 7 BCE, 7,400, and will return again at 18,400 CE. Iota Herculis was 10,800 BCE, will again be at 15,000 CE. Alpha Lyrae, also known as Vega, was pole star at 12,000 BCE and will be again at 14,500 CE. Alpha Cygni, Deneb, it will be our pole star in the year 9,800 CE. Beta Cephei, it will be our pole star at 5,900 CE. Delta Cygni will be the pole star at 11,250 CE. Alpha Cephei, it will be the pole star at 7,500 CE, not BCE, CE, Common Era. Iota Draconis, it will be our pole star at 4,420 BCE. And Iota Cephei, no data. Southern Hemisphere. Sigma Octantis. That is the pole star today. Now, Sigma Octantis is kind of a pathetic thing.
6 magnitude.
No, 5.5 or 5.4, depending on your source. And it's at the pole, it's Polaris Australis at 270 light years away, but it's 5.5 magnitude. That's tough to use for magnification if you're anywhere in a southern hemisphere, more equatorial place. It is approximately, I got two sources, depends on the age, either 120 light years away or 270 light years, and it is going away from us at 11 kilometers per second. The distance to the south celestial pole now is approximately 1 degree, maybe 10 minutes. It was much closer to the south celestial pole in 1900 than it is today, because the pole is pulling away from the star or vice versa. So Sigma Octantis, also known as Polaris Australis, fine. Beta Hydrae, no datum. Eta Hydrae was the pole star in 100 BCE. That was the peak of the Han Dynasty and the Roman Empire. The Republic was gone by that time. But that's what they were using for the southern pole star. But who in the Roman Empire or the Han Dynasty was far enough south to use it? All right. These things mean a lot to me. So, Alpha Hydrae. Alphard, it was pole star in 1000 BCE and will be a pole star again in 10,700 CE. Gamma Chameleonis, it will be the pole star in 5,000 CE. Omega Carinae, it will be the pole star in 6,800 CE. Upsilon Carinae, it will be the pole star in 8,500 CE. Iota Carinae, it will be the pole star in 9,000 CE. Delta Velorum, it will be the pole star approximately the same time as Iota in this. Delta Velorum will be a pole star at 9,000 CE. I think there's a typographical error. Alpha Carinae, Canopus, to be the pole star in 14,000 CE. Alpha Canis Majoris, Sirius. This I was not expecting at all. This I was not expecting. Sirius will be the pole star in 66,270 CE, and it will come back as part of the Great Gyre in the year 93,800 CE. New Puppis, the pole star, South Pole Star, in 13,500 CE. Omicron Puppis in 12,000 CE, which was before the previous reading. Omicron Velorum in 9,400 CE, and in K Velorum 8,500 CE. Now, depending on the proper motion, they've all got a whole bunch of different proper motions. Some of these stars, when they come back, will be maybe a disappointment as a pole star, or maybe even better. And yes, Jeff, you're quite right that to do any kind of a reckoning, and planetarium programs can do that, one must take into account the proper motion, and not just the motion of approach or receding. You're quite right about that. In fact, was it to Narlock? Was it almost 20 years ago? We were given a planetarium show there with the new planetarium. And I said, would it be possible to show the the heavens in the year 8,207, 8,207 and 1? And he said, yes. But of course, he's not guaranteeing accuracy. So what is the significance of the year 802,701? Anybody, any takers? Where's Trombley? What is the significance of that number, of that year? Hey.
Time machine.
Got it. I knew I could rely on you. Yeah, all right, enough of that. It's time for me to go home. Thank you, that's it.
The ELO didn't participate in this trip.
All right. Hmm. All right, everybody. Well, thank you very much for joining us tonight. After astronomy, we do our customary gastronomy at the Redcoat Tavern on Woodward, just north of 13 Mile. Hope to see as many of you there as possible. And drive safe and grab a bottle of pop on your way out the door. Our next meeting will be on the third Thursday at Macomb Community College. See you then.
There's an almost full bottle. Take a full bottle. Would you?
Recording stop.